So what's a good idea on how to solve this one?
Maybe like find the whole volume of the prism and then subtract it by the cone.
Perfect, yeah. So find the volume of the whole prism and subtract out the cone. Does it matter which order you do the problem that, in terms of those two things? Like, okay. But let's start with finding the volume of the prism. And there's a piece of information given in the text that is pretty critical, but not given in the picture. Okay, so I'm just drawing the prism for now. What of the three numbers in the picture should I put in this? It's kind of what we've been calling zoomed in sketch. Like, what needs to be on this picture to find the volume of the prism? Okay. Length, width, and then there's one in the text that we really need for sure. Yeah, and so it says the height of the triangular base. That's this. Okay, so we have big H, we talked about this on Friday, big H for the height of the prism, and little h for the height of maybe a trapezoid, or in this case a triangle. Okay, and it's important to keep those straight. So, volume of the prism in general, let's review also. We're not just solving this, but also reviewing. So, volume of any prism, so general form is what? Perfect. Base area times height. Okay. In this specific case, so now for a triangular prism, how do we find the base area? In other words, what's the area of that triangular base? Close. That's for a rectangle.
Half times base times height, so 22 times 12.
Yeah, times a half. Okay, and then the overall height of the whole thing, right? So we're going to call that big H. Everybody good on that? Just quick reviewing formulas and stuff. Okay, so we're going to find 1/2 times 22 times 12 times big height of H. Let me write that in color. Okay, and then from here it's just calculator. So what did you get when you multiplied all that stuff together? And did it give us units in this? Centimeters. Centimeters what? Cubed, yeah, good job. Okay. Now, like Kyron said, we need the volume of the cone so that we can subtract it out. What's the formula for volume of a cone? It does have a set formula that we use every time. Yeah. Okay, and now this h is height of the cone, which happens to match the height of the actual prism. Which it presents a little bit of a problem, because do you agree if we're drilling down in here and it's the exact height of the prism, there's probably going to be a little pinhole at the bottom, right? Where the tip of the cone is drilled. Probably. We could hit it perfect, but it certainly wouldn't be a thick layer at all. It would be right at the same level. But that's okay. That's kind of a conceptual thing. So what are R and H that gets plugged in?
3 squared times 8.
And 8, yeah, good. So 1/3 of 72 is 24, so this becomes 24 pi. And what is that? It's back to, like, 1/3 and pi almost cancel each other, so we're kind of back to close to 72 again.
$75.3
Alright, let's go with 0.4. Everybody good on 75-ish? Okay, then just subtract. So volume of the overall shape is what? Like just under 1,000. 900. I'm looking at you, you have your calculator right there.
980.6.
Karen, are you good on that? Okay. This is a composite area, meaning it has two things going on, right? There's all sorts of different kinds of problems that we could do that. Although I said area, I meant volume, so it's a composite volume problem. Anybody get 980? Any questions on the process of how we got 980 at this point? Okay. So when I say composite, hopefully that means to you that we're combining shapes. In this case, that's what it means. So in this case, we pulled out a cone. What if we added a cone to something? Yeah, we would add, right? Are there shapes like that? Yeah, I mean in real life, are there shapes that are combinations of different base shapes? Can you think of one as an example? There's super common one that you're part of every day. Tell me about a house. What's it a composite of?
Well, there's probably rectangles, squares, maybe like windows.
Okay, but we're thinking like volumes or surface areas. So,
Roofs.
okay, what shape is the roof of a typical house? Triangular prism, yeah. So if I said, what's the volume of the attic up there? You know, for heating purposes. They say your attic ventilation should refresh or recycle your air through there about three times an hour. So you have to kind of know volume in order to size your venting properly. Okay? Triangular prism roof and attic part. Okay, what's the bottom called? Yeah, right? So now we have to do a rectangular prism if I said volume of the whole house. Or maybe if I said, what's the surface area of the whole thing, right? Now we have to do two different types of shape for that. Okay, we're not here yet, but here's a couple. We're going to talk spheres today in a minute. But here's some. There. Have you ever seen one of these go by? All the time, right?
Mm-hmm.
What's it a composite of?
Coal.
No cones.
I said coal.
Oh, well, this isn't coal. This is liquid.
Oil?
Yeah. So the sides are a cylinder, right? What are the ends?
Circular.
They are circular, but they're called a sphere. Well, a hemisphere or a part of a sphere. Same with these, right? Like a propane tank. There's a pill. That's the same shape. So cylinder and sphere. Here's those propane tanks, cylinder and not a whole sphere, of course, but part. Okay, so composites definitely exist around us. Do I have any more? Oh yeah, what does that look like? Ice cream cone. We better study that, right? How about that?
Like a skyscraper?
Yeah, maybe a skyscraper or some kind of tower. I went to an elementary school actually that had this kind of shape.
What?
It was like someone chopped the building in half. It was the weirdest looking thing.
That's weird.
Yeah, it was super strange.
Actually, my old middle school, it's still around, but my middle school kind of had that shape.
Did
in
it?
front. Yeah, kind of.
Which one is it?
Independence Academy.
Okay. There's a different version of a house where you have, instead of triangular, it's trapezoidal. That's definitely common. Okay. Or maybe like a barn. Probably more common for that. All right, so these kind of shapes are definitely something we have to encounter. Do you feel confident in just adding or subtracting volumes? Okay. All right. Let's back up just a little bit. And, oh, real quick on this one. Have you ever had something like this says smoothie or like an ice cream, like a milkshake, I mean, in a glass shape like that? What is it wanting us? It says which is the better deal. So it's giving a price and dimensions. What do you think it wants you to do?
The volume of each cup and then convert it to price to see which one gives you a better deal.
Okay. For what shape?
For a cone.
Yeah, even though it's not quite, right? But we could approximate it as a cone. Alright, so let's do this one to practice cones, and then, actually we just did a warm-up on cones. Which one is harder, cones or pyramids? For you, I'm asking you individually.
Pyramids.
Pyramids? Same? Okay. Alright. Well, if you feel okay with cones, we don't need to do a cone problem then. Even though I think cones are probably more common overall. Let's do a composite with a pyramid. Like the skyscraper. Okay? So it says find the surface area of each composite. And let's change that. We can get this off here. Let's just change that to volume so we can practice that from Friday's work. And we'll worry about surface area another time. Sound good? So volume just of the skyscraper problem of that guy. So 5 minutes. Alright, so we have found the volume of the base prism. So triangular prism that's kind of holding this pyramid up, which we got 276, and then we're working on finding the volume of the pyramid at the top, which is a triangular pyramid, so a third of any pyramid. But the volume of any pyramid is a third of the prism. And then in this case, our prism is a half base height. And we don't know the height of the pyramid, so that's what we're about to do just now. So if you can think of this kind of being a pyramid, we need this big H height of the whole thing. So what are the dimensions that we can put into trying to solve this? I'm going to take off the little that 3D part just because I think it makes it harder to see. So we're looking at a slice down through the middle of this pyramid. So how long is one of the diagonals? It's one of the perpendiculars of the face, right? One of the altitudes. So it's 7. And then how long is this overall? This is thinking cutting across the triangle face.
16 inches.
Oh, did you say 16?
Yeah, just 8.
Well, but the 8 it's the side lengths of the bottom triangle. I'm talking about cutting down through the middle of the triangle.
So 8?
No, that's still a side length. I need a pyramid. I don't have one. Tell you what, let me look for. That is not through the tip, but do you see how if we cut through there, it's making this purple triangle? Okay, so what do you think would happen if we just slid that orange slicer back to the tip? Right? Like if we took this is like think of like a knife blade slicing down through right here. Why isn't it? Oh, it's some springs. Alright, cut through. We are making a triangle. So if we slide this orange slicer back through here, through the tip of the pyramid, isn't it going to still make a triangle, only a little bigger? Right? It's just going to get bigger as we get closer to the top. Does everybody kind of see that? So this length is this length right here. And this length is the edge of the whole pyramid. Okay? So in ours, what is that length? Like, you have to kind of turn your image now, because this is the known length. How long is that whole base? Yeah, good. That's the 6.9 inches. Okay? Are you seeing it now? So how do we find h? Well, first of all, this is going to be perpendicular. That's, by definition, the height of a pyramid is perpendicular. So how do we find h from that? Something we've used a whole bunch of times. Yeah, but are we using the full 6.9? No, because it's only half, right? So we're going to zoom in one more time. What's half of 6.9? Alright, go ahead and solve for h, and then we'll go plug it in over here. Guys, this is a square or rectangular pyramid. But do you see how that slice through the tip of the pyramid makes a triangle with a slanted face? Are we seeing that? And if we can just imagine this bottom being a triangle, that helps a little, I think. Alright, what'd you get? This should have been h squared plus 3.45 squared equals 7 squared. So 49 minus, this is probably what, like 12, 13? Okay. So what'd you get on the right side? 49 minus, like, 37.09. Okay. And then square root to get h. Okay, so that is our height of our pyramid sticking up here at the top. Alright, and then we just type all that mess in our calculator for the pyramid on the top. Where? Did you get that? Also, Silvana? I'm just looking for people who are done punching numbers. What can you say what you got again?
56.028.
Okay. That anybody else got? Let's just call it 56, okay? Because it's pretty darn close. Okay, so we have 56, and then the whole thing we add to the prism. So let's just call it the total volume, 56 plus 276. Kyron, how about Kyron does this one? Fast fingers, Kyron. That one was deep, huh? Did anybody catch that before we checked it? Okay. So here's my advice. I'm going to use this picture. If you're given that slant height, be careful. You can't just plug it into our formulas, okay? So know that you're going to have to find the actual height, not the slant. All right, you're going to have some practice on this, but I want to talk about spheres real quick. or I'm past that. So grab your notes and we'll put that in here. Again, these last, like cones come up some, but pyramids and spheres, like in your daily life, you're not really going to deal with a ton of those. Spheres, maybe. Pyramids, when was the last time you dealt with a pyramid? Somebody should make an ice cream pyramid. That would be cool. Like a geometric, like a Minecraft ice cream cone.
I don't think ice cream could stay cold on and made it into a pyramid.
No, I'm saying the cone part. Make that, instead of a cone, make it a
that's possible.
pyramid shape. Yeah.
It's probably possible.
Alright, so volume and surface area of spheres. These formulas are, again, we have formulas. Let me start by saying that. So that's nice. You just plug stuff in. But you do have to be careful because they're a little bit similar. So we don't want to mix them up. Is everybody clear on what a sphere is? Okay. When my son was little, I used to call it a sapphire. It was cute, but sapphire. Alright, let's do volume of a sphere first. Guys, what is the defining dimension of a sphere? They're cool because just like a circle, I can tell you one piece of information and you know everything about it. Whereas prisms, we need height, little, like big height, little height. We need side lengths, bases sometimes. But with spheres, we just need one thing. What would that be? A diameter would work, or a radius. That defines the entire shape, which is very cool. Okay, so the volume of a sphere is 4/3 pi times radius cubed. You know it's a volume because it tells you r cubed. And then surface area of a sphere is just 4 pi r squared. So it's basically the circle formula with the 4 out front. So formulas, again, they're nice because you can just plug stuff in. And in this case, you only have to plug one thing in, which is r. So I think spheres should remain fairly friendly. I think it's probably worth reminding you of this word. So what is a hemisphere? Yeah, half of a sphere. So thinking of the little pill capsules, the propane tank, the oil tanker train car, that have a cap on the end that's part of a sphere. If it's a hemisphere, you just take half of the sphere, right? Half of the area or half of the volume. It may not be that. It might be like a sixth of one or some other fraction. But in that case, we'd have to be told that. Do you come across hemispheres in life? I mean, you live in one. Right?
Live on one.
You have sometimes road. Has anybody ever driven in Texas before? Yeah, they have. It might be true of other places like this, but sometimes they put these hemisphere-shaped. I don't know what they're made of, hard plastic or maybe metal, along the road lines, and if you run over them, it's like they're about
Speed
this
bumps?
big. No, they're not speed bumps. And you call them turtles. That's kind of what they look
Oh
like.
yeah, turtle.
Turtles.
Is it like a speed? Is it like a speed?
It's, I think, to help keep lane lines marked when it's really heavy rain. Because have you ever driven in a rainstorm and at night and you lose the lane lines totally? You can't see it because it's reflecting. I'll try to pull up a picture, but they're kind of hemispherical shape. The top of a fire hydrant sometimes is hemisphere, but I don't know about stuff that you'll calculate.
A bowl.
A bowl, duh. Good job. Sheesh. Okay. Got those. Surface area. That's really easy. Oh, real quick. Let's talk about this one. What does this C stand for?
Circumference.
Yeah, so we saw a problem like this last week. If we're trying to find the surface area or volume, either way, we need the radius. So how do we get radius from a circumference? Any thoughts? Okay, why don't we put this one in your notes as an example? Do you see how, and I did this in our note, I don't know if you copied it, but do you see how for drawing a sphere you can do like a solid line and a dashed line? It kind of gives it a 3D effect a little bit. So try to do that when you draw this in your notes. That looks like an egg now. Does that look more spherical to you guys out there? Alright, so here's how you do that. I could give you maybe the area of a cross section or something at the diameter. But for this, what is the formula for circumference? Good, it's pi times diameter. Here, let's title this to find r from circumference. Alright, so he said that it's pi times diameter. That's a good one to have memorized. In this case, we're told that C is 12 pi. So plug 12 pi in for C. And then, of course, pi you can't plug in for. And then we'll solve for D. So how do I get D by itself at this point? Divide pi off. Okay, and then D is 12, but we don't want D, we want R. So what is R? Okay? So r is just like half of your diameter, radius is half the diameter. Any questions on that part? Okay. And then for circumference, we're just plugging in what we just found. So circumference of the sphere, 4 pi r squared. We just found out that r is 6. So 36 times 4 is 144. And we'll just call that in feet. This is feet. Feet squared. What if I gave you a surface area and asked you to find the radius? How do you find the radius? Let me ask that again. Just now we found the surface area from the radius. What if I gave you the surface area and asked for the radius? Do you want an example of that? I mean, it's not really so much geometry. It's algebra. Are you guys good with SA? I keep abbreviating. Okay. So the surface area of a sphere is, let's say, 400 square inches. What is the radius? What is the volume? We'll just kind of combine these two examples. Well, what's a good first step? What's always a good first step with this kind of work?
Draw your shape.
Sure. So we have a sphere. We don't know anything about it. Well, we don't know any dimension about it. So we can't put any numbers on there yet. We do know the surface area is 400. So what's a good next step?
Label it.
We don't have anything really to label it. Yes, you would want to do that if you knew something. But like we don't know radius or diameter. And it's kind of hard to show a surface area. Okay, so here's the next step. Write a formula. Write the formula. Well, in this we're going to be working with two different ones. We have a surface area and a volume. So write both. And then plug something in somewhere. What do we know? Out of both of those formulas, what do we know? Go ahead, Simone. Yeah, right? So, step 3, plug known information in. So the only thing we know is surface area is 400. But that's all we need to solve for something. Okay? In this case, we're solving for the radius. So step 4, solve for unknowns. How do we get that radius by itself? What was the first thing you said? Yeah, and pi, you're right, but how? So get rid of 4 and pi. You can do it at the same time if you want to.
Divide both sides by 4 pi.
Yeah, because it says 4 times pi times r squared. So we can divide 4 pi off. Well, 400 divided by 4 is 100. 100 over pi. Don't copy me, I need to fix it. Okay, that's not going to be a whole number, which is fine, but if we were in algebra class, I would just make you simplify this and rather than calculator it. But how do we get, let's go ahead and do 100 divided by pi, you're going to get roughly 30.
31, 32.
Yep, let's just go, oh, you said 31.83.
Yeah.
Let's do 31.8. And then how do we get r by itself? Square root both sides. And Bailey, what's that?
It's 5.6.
So we have the radius, and now how do we find volume?
4 over 3 pi times 5.6.
Yeah. Did you notice it's the same steps? So draw it. Well, now we can go label a radius. Now we can put in here that the radius is 5.6. Okay. Write the formula. Check. We did that. Plug known information in. Well, now we know that R is 5.6. So we just plug that in as our next piece of known information. Good. Now you just hit buttons to get what? It'll be a fairly decent sized number. Probably over 1,000. Here, I'll plug it in here. 4/3 times pi, oops, that's E, times pi, times 5.6 cubed. Nope, that was a little too high. Oh, it's because I did to the 4th. I did something wrong. That's
735.6.
yeah, good job. Anyway, that is units cubed. No, I didn't give you units, but that's what that is. Cool. So guys, see how sometimes you might have to solve for a piece from a given surface area or volume, like solve for the radius, instead of solving for the surface area given the radius. It's just a little bit of twist on the algebra part. Otherwise, it's not really too bad. How do you solve for surface area or volume of a hemisphere? Don't overthink it.
Use order spheres.
Do a sphere, and then
But
no, you do the same thing. Solve for a sphere, and then just cut it in half, right? Just like if this was actually like a gumball, and I said, what's the volume of the top? Solve for the whole thing and cut it in half. That's all for a hemisphere. Okay. How about one of these things?
solve for you solve for 2 hemispheres and I can't remember the
Say it. You guys can speak without me calling on you.
cylinder.
Yeah, good job. So 2 hemispheres and a cylinder. Assuming that we're told that that's a hemisphere, okay? I guess in this case it doesn't, does it say that? Maybe it does and I chopped it off. How about that? See how it says cylinder and hemisphere? Okay. Do you feel like you're ready to practice?